All right. So we had learned about medians and centroids right before break. And the centroid, does anybody remember what a centroid is? Close. Not angle bisectors, but medians. You're thinking circumcenter is for perpendicular bisectors and incenter is for angle bisectors. So the way I keep that one straight, angle bisector starts with a vowel and incenter starts with a vowel. So the two that start with vowels go together. Centroid is the intersection of the three medians. And what does a median do? Like, how do you know if a segment is a median versus an angle bisector versus a perpendicular bisector? How would we know what a median is? We wrote this definition down before we left, so if you want to flip back, what is a median? Yes.
A segment that goes from a vertex to the opposite side.
Goes to the opposite side. What special point on the opposite side does it hit? The midpoint. Medians go from the vertex to a midpoint on the opposite side. So when it tells us that D, this point right here in the center, is a centroid, I immediately know what about points B, C, and F? They're midpoints, yes. So if F is a midpoint, what's true about EF and GF? They are congruent. C is also a midpoint. So what's true about AC and GC? They are congruent. And B is also a midpoint. And so AB and EB are also congruent. So that's one of the first things that you should notice and mark down when you are told about a point being a centroid. Centroid means medians, medians mean midpoints. There was another special relationship that we talked about when it came to the centroid. When I look at just one median, so if I look at just this median, for example, do you see how there's a shorter piece of the median? It goes from the centroid to the midpoint. And there's this longer piece of the median from the centroid to the vertex. There's a really special relationship between those two segments. And that special relationship is that this shorter piece right here, from the centroid to the midpoint, is half as big as the distance from the vertex to the centroid. So we call the distance from the vertex to the centroid 2x, and the distance from the centroid to the midpoint x, to show that it is half the size of the other one. And that's true about all of these medians. So this median right here, the short part, the part that goes to the midpoint, is x, and the longer part, the part that goes out to the vertex, is 2x. Looking at this median right here, the portion that goes out to the midpoint is x, the portion that goes out to the vertex is 2x. The longer portion is 2x. And so the whole median would be how many x's? 3 x's. All right, let's see if we can take this information now and answer the questions that they've given us. It says that AF would be this right here, is equal to 18. How many x's is from A to F? 3x. It's the whole median. Here's 2 x's to get from the vertex to the centroid, and then another x to get from the centroid to the midpoint. So this is 3x here. So 3x equals 18. Well, if 3x equals 18, then how big is x? X is 6. The distance from A to D right here, how many x's is that? 2x. So 2x would be 2 times 6. You're right, that would be 12. And so then the distance from D to F would be how big? 6, because that would be x. All right, let's look at one of the other medians now. Let's look at, let's see, it tells me ED, this much right here, is 27. How many x's is that? 2x. It goes from the centroid to the vertex. So that's 2x. 2x is 27. Divide both sides by 2. And that means x is how much? 13.5. Yes. Well, if from E to D is 2x, how many x's is from E to C? 3x. So E to C is 3x, and we just said that x was how big? 13.5. What is 3 times 13.5? 40.5. And how big would it be from C to D right here? X, which is 13.5. Nice work. All right, we've got one more median to look at. Let's see, BD, this distance right here, it tells us is 19. Is that 1x, 2x, or 3x there? 1x. So 1x is 19. I want to figure out the length from D to G, this part right here. How many x's is that? 2x. So that would be 2 times 19, which is 38. What about if I wanted the distance from B all the way to G? How many x's is that? 3x, because that's the whole median. So we would do 3 times 19 to get that full distance, which gives us 57. Nice work. All right. And then we just have part D. It tells me that EF is 2h plus 10. So this distance right here is 2h plus 10. And it tells me that FG, this distance right here, is 32. Well, what did we say we knew about EF and FG? They're congruent. EF is congruent to FG because F is a midpoint. And if those two segments are congruent, then what do we know about their measurements? They are equal. So EF, measurement of segment EF, is equal to the measurement of segment FG. So that means 2h plus 10 is equal to 32. So then I'm going to subtract 10 from both sides. 32 minus 10 would give me what? 22. 2x equals 22. And then we're going to divide both sides by 2. And that means we find out that x is how big? Or sorry, not x. What should I have been writing this whole time? H. Thank you for correcting me. Should be h, not x. My apologies, guys. Let me go through and fix that. There we go. So h is 11. Very nice work. What I would like to do is to give you guys about 5 minutes to work on number 9 by yourself. Number 9 is almost identical to number 8 in the ideas that it's asking you to walk through. You could also look back at number 7 from before break. So like I said, I'm going to give you 5 minutes to work on that one, and then we're going to go through it together to check your answers. And I'll be walking around to help you guys if you need help. Go through, label your congruences because of the midpoints first, and then label your x and 2x relationships next, before you even start looking at parts A, B, C, and D. Mark your triangle up with your x and 2x and your congruences because of the midpoints. check your work with mine. What do we know about points S, T, and U? They're midpoints. So we know that QT and RT are congruent. We know that UP and UR are congruent. We know that SP and SQ are congruent. Perfect. All right, now let's go in and label the parts of these medians. Let's start here. Would this be an X or a 2X? X. Let's move counterclockwise. So this one right here then would be X or 2X? 2X. Moving down here. X. Here. 2X. Here. X. And the last unlabeled one up at the top here. 2X. Perfect. So those X and 2X relationships hold for a single median. What I am saying is that this part SV is half as big as this part RV. I am not saying that SV and VU are the same size. All right, so let's look at what we've got. What segments are drawn in the picture? What are those segments? What do we call this right here? Median, yes. Those are all medians. Part B, if VU equals 8, then QV equals and QU equals. Let's go look at VU. Here's VU. Is that an X, a 2X, or a 3X? X. So that means that X is equal to 8. If X is equal to 8, then what do I need to do to figure out the size of QV? Times it by 2. So I would have 2 times 8. And 2 times 8 is going to give me 16. What about QU? 3 times X. So that's going to be 3 times 8, which is 24. Perfect. All right, next one. VR is 22. Is VR X, 2X, or 3X? 2X for VR, because we go out to a vertex. If 2X is 22, then how big is X? 11. We would divide both sides by 2, and we would get that X is 11. So then we have SR. Is SR 1X, 2X, or 3X? 3X. So I would have 3 times 11, or that would also be 33. And then we have SV, which would be how much? SV is X, and X is how big? 11. X is 11. D, QR. Is QR part of a median? No. QR is one of the sides of this triangle. Here's QR. It says it's 8y minus 16. Right? And then we have TR is 3y plus 7. TR, 3y plus 7. What's the relationship between QR and TR?
TR is half of QR.
TR is equal to half of QR. Beautiful. So how many segments that are the size of TR would it take to make the segment that is the size of QR? It would take 2 of them. If I have 2 segments the size of TR, that would give me a segment the same size as QR. So if I do 2 times 3y plus 7, that would be equal to what? 8y minus 16. All right, so I'm going to take this 2 out in front. I'm going to distribute that. So I'd have 2 times 3, which gives me 6y. 2 times 7 is 14. So 6y plus 14 equals 8y minus 16. And then from here, I'm going to get my y's to the same side. So I'm going to subtract 6y from both sides. I get 14 is equal to 2y minus 16. Then I would add 16 to both sides. What is 14 plus 16? 30. So 30 is equal to 2y. If 30 is equal to 2y, then how big is y? 15. Divide both sides by 2, and we get that y is 15. All right, so if y is 15, what do I need to do to find the length of QT? Find the length of TR. Because QT is congruent to TR. So the length of QT is equal to the length of TR. So QT is equal to 3y plus 7. Which means I'm going to do 3 times 15 plus 7. What is 3 times 15? 45, and 45 plus 7? I'm sorry, how much? 52, thank you, I just couldn't hear. So QT is 52. All right, one last part to this question to solve. Is PT a side, a median, or part of a median or a side? PT is a median right here. How many x's is it then? 3x. So I have 3x equals 27. Well, if 3x is 27, then how big is x? X is 9. All right. So how big then is PV? 18, because that's a 2x. So we would do 2 times 9, which is 18, and that means VT is how big? VT is 9. That's x, so that would be 9. Very nice work. We have approximately 16 minutes remaining between now and the bell that starts the announcements. I'm going to give you guys the remainder of that time to work on the homework that is due tomorrow. I will be moving around the room offering help and support. You can find problems to help you with the ones on the homework on pages 7, 8, and 9 in your notes. Pages 7, 8, and 9 in your notes.